All right, so the cable company does continuous what? On the program it says continuous delivery what? They kind of made me put the delivery in there. I hoped that everybody would understand what it was we were talking about, hence the title on the slides. I am Joe Campbell. I have been a professional programmer for about 15 years. I have about 3.5 years in at Comcast. My main job, or the elevator pitch that I like to give people for what I do, is I like to help developers go fast. I don't necessarily strap rockets to them, but what I do is help impediments get out of their way. So I'm looking at all of the various problems that they have and trying to come up with good solutions for those things, hence the other bullet. And I'm a very pragmatic dude.
And hi, I'm Wally Eggert. I've been with Comcast for about 2 years. I'm a team lead at Comcast, so I'm more of a hands-on guy, building software, delivering it. I've been programming for a bit longer than I care to admit, but I love it. I love making software work. I love making software simple and reliable. And often the code that I write today is in production tomorrow, and that's a good thing. So I'm going to tell you why.
We both work in this wonderful glass building downtown. I'm sure you've seen it. Unfortunately, we don't work anywhere near the top. We work a hell of a lot closer to the bottom. But we haven't started any fires and we don't have any staplers, so we're good there. As a matter of course, we do have to start with a few provisos and disclaimers. We are going to talk about some of the tools and things that we as a group within Comcast have chosen to do continuous delivery. They are by no means an endorsement of those things. They are just the things that we happen to have chosen. Your mileage may vary if you choose the very same tools. So we're going to talk about where did we start in our continuous delivery travels? What did we have to start from? So sort of the basic, like here are the building blocks that we had to go from when we started out. We're going to talk about how we did it. We're going to talk about what did we get out of it. And we're going to talk a little bit about underpants gnomes as sort of throughput to this whole thing. So when we started, it was a little bit like the Wild West. When I started with Comcast, I spent my time trying to figure out who it was that I needed to talk to in order to gain access to the software that I needed to do my job. I discovered very, very quickly that even within the small group that I am part of within Comcast, we're about 150 people, there was 2 different code repositories, both of them Subversion. They were owned by 2 different people, or 2 different groups, in the same subgroup of Comcast. As I continued to go a little deeper, there were 2 Maven repositories, because each group had stood up their own Maven repository for the Subversion repositories that they were using. There were 2 different CI tools used by each of the 2 groups. And it was like, well, you know, is it really anything worth doing once is worth doing twice? There's too many of these things. We're all doing the same sorts of things. We had an ops group, an operations group, who spent a lot of their time doing our deployments. They were hands-on. They would take code from somebody, and ironically enough, usually it was from somebody's laptop rather than a server that looked like the thing they were supposed to be deploying to. And then they would go and put hands on physical servers and deploy their code. We also had these wonderful deployment calls, very Gantt chart-esque, as you can well imagine, that would last, depending on the group, anywhere from a half an hour, if it was a particularly quick deployment, to multiple hours in a day. So there were some that would go for 4 or 5 hours in a day because we have X number of servers. They want to make sure that everything's operating correctly. They would deploy to some number of them, verify everything was right, deploy to the other of them in one data center, then they repeat the process for the other data centers. So there was a lot of this rigmarole. So if we were looking at the overall checkbox, we sort of had development splintered, but it was there. People were doing it. They were testing. They were verifying. We had testers that were doing that. Okay. We were sort of staging, although again, staging was sort of laptop-ish. Sometimes it was builds that happened in CI, sometimes it was people's laptops. And then there's a whole variety of like deployment issues, and we sort of like, there's too much here and it's not working right. So we ended up with the feeling that we were really scratching the surface of an iceberg, right? We were only seeing this very little sliver at the top, and there's all this that we could be doing underneath to try and alleviate that problem. So when we talk about that, we talk about the underpants gnomes. We say, okay, we're doing some things, we're sort of collecting underpants. There's something that happens in this other phase where we do some other work, and at the end we profit. Yay. Well, we want to give you all the stuff that's in the middle. We want to try and answer that question mark for you.
So we need to decide, how do we start? I was fortunate enough to join Comcast about when we were getting started on this process. And we knew we wanted to do continuous delivery. We didn't quite know how to get there, but we had to start somewhere. So let's pick a project. So we went through some decision process to decide which project. We threw darts, we did rock, paper, scissors. What we really did was we picked a greenfield project. We picked something that didn't have a legacy to deal with. We put a small, experienced team on the project, a team that believed in continuous delivery, that understood it. We planned for some extra upfront investment on this project so that because we knew we had to build out infrastructure to do this right. And we let the team do their thing. We didn't try to push too hard. We just got started and prioritized doing continuous delivery properly.
So we point out too that the team that was doing this was preformed. So we started with an existing team. We didn't select them as this process came up. They were already in position.
First step was to automate our CI and our deployment. So we put together a really simple automated CI environment. So continuous integration. So basically you check in code, it does an automatic build, gives you feedback on that build right away. And we put together a simple deployment script that deployed our code automatically to an environment as soon as the CI build completed. So this was our very basic first step. Nothing manual. You commit your code, and the next thing you know, it's running in this dev environment. And that allowed us to start rapidly deploying changes to this simple endpoint. So this is a start. And it's a really good way to just get your feet wet and figure out, what is this going to take?
Usually too, dev is entirely in your control, so it makes it really simple to take control of that and say, we're going to do this new thing and we're going to make sure that stuff gets automatically put to it.
Yep. And in fact, we even took advantage of some cloud computing resources, which made it even more under our control to get this started.
I forgot about that.
We did.
Yeah, we used Amazon or something akin to it to make that easy.
So as soon as we started scripting our deployments, that got us thinking about the deployment environment. We had all kinds of different deployment environments available to us. That's probably not a good thing, but it gave us a good selection to start from. So we picked what we figured was the most forward-looking environment we could find, and we created our automated deployment scripts to work against that. And we started evangelizing that as our platform moving forward. We also started deploying to more environments. We created a second environment also in the cloud, just so that we could say we had 2 environments and have our pipeline going to multiple places. And eventually we were able to bring that back in-house and get that into our QA environment.
We should note too that it required a little bit of convincing that there should be some commonality between these environments. Because when we started out, there wasn't commonality between any of the environments. Ours were definitely not alone. When we looked across all of the things that we deploy to, it was like, we're deploying WAR files. We're always deploying WAR files. They just happen to always go to Tomcat. But the Tomcats across the environment were configured widely differently. Different memory footprints, different number of Tomcats installed per box, different operating systems on each one of the boxes. So part of this was actually going through the exercise to try and convince people that there was actually value in saying, we're doing the same thing over and over and over and over and over again with the same stuff. So we should probably figure out how to make the environment smaller, make the surface smaller, so that when we do a deploy, it happens in the same way to all of them.
And in fact, automating the deployment is a good forcing function to force that consistency. You can't automate over divergent environments very easily.
Well, you can, but you end up in the same boat with different environments, different code, et cetera, et cetera. You lose the value.
So we started measuring our test coverage. This is Cobertura, made that part of our continuous integration so we could get some visual feedback on how well we were doing with our unit test coverage. And we discovered pretty quickly that it was quite lacking. So everything starts with unit test coverage. A lot of effort goes into that. We aim for the mid-90s in our code and branch coverage in Cobertura. That takes a lot of work, but it is absolutely worth the investment. We enforce this test coverage. So we have, as part of our CI builds, we have a rule that checks the Cobertura coverage, and if it fails to meet the limits, then it fails the CI build. We have to go back and fix it. And at every opportunity we have, we ratchet up the code coverage limits to try to make us do better. And that way we can't revert back to our old ways. The reason that the unit tests are so important is that that's our safety net. We're going to have other levels of testing coming, but unit tests tell us when we refactor a class, did we change its behavior? If we intended to change its behavior, we change the unit tests, and we can clearly see that changed behavior and review it and understand it.
Unit tests are interesting because a lot of people will pick on the fact that our coverage is actually in the mid-90s. Remember when we started this, it's a greenfield project, so we have the opportunity to sort of do that in advance. For projects that aren't greenfield, the ratcheting helps, because basically what you're doing is you're providing visibility to the fact that there's not good unit test coverage in the thing that you're trying to continuously deliver. And when you lack that unit test coverage, you're actually going to end up in a really bad spot. Because what's going to happen is without the safety net, somebody's going to make a change, and if continuous delivery is really how you're going to do it, somebody will come along, they will push the button, and something will go wrong in prod. It happens, but if your coverage is something like 10%, then set the ratchet at 10% and just make sure that it doesn't fall any less than that. As you continue to evangelize with your team to drive it up, ratchet it up as you go along. And that keeps them from sliding back. It keeps people in visibility of the fact that unit test coverage is a certain thing. And it's important for a variety of reasons.
So then we move beyond unit tests. So unit testing covers us for refactoring, covers us for newly created classes. But we also need integration testing, or testing with other systems. We need functional testing. We're really big on functional testing. In fact, we've divided our functional tests into 3 different categories. We have what we call smoke tests that we run against nodes as we deploy them into an environment, individual nodes. We have single node tests that are run against a node that needs to be staged in a certain configuration or a certain state in order to run those tests. And we have what we call basic tests, which are the main functional suite that we run against the load balancer in an environment in order to test the outward-facing functionality of the system. We've put a lot of effort into developing these tests.
And everybody runs them. So in addition to the CI, the continuous integration that runs these tests for us, the deployment process that runs them against the various nodes, they're available to be run by each and every developer as well. So for instance, we have developers that have it as part of their habit now to run the full suite, not only the unit tests, but all of the functional tests for the things that they change and their development as they go along. And I think, at least on one of the primary projects the 2 of us works on, we're now up over 1,400 total tests that run 2 minutes or less.
Yes.
So the cost of running that number of tests is very, very low, meaning every developer actually has the habit built in now to run them because it doesn't cost anything. It's like, okay, here's a command line, run it on my command line. Oh, look, everything passes, great, green. Go ahead and push it up to the repo because I know CI is going to pass.
We also make functional tests a requirement for completing a story that we're working on. So if we're implementing a feature, we need to implement the functional test before we move on.
That's on me because I'm the product owner.
So as quickly as we could, we deployed to all environments. That includes production, even if nobody's using it, even if it doesn't do anything terribly useful yet. The idea being, let's pave the path for continuous delivery. We want to know what our connectivity problems are going to be early. We want to get our build pipeline working efficiently. We want to practice over and over again in all environments. So we deployed our application to production very early and practiced over and over again.
To be sure, though, that required a little bit of convincing. Not everybody was sort of bought into the idea. We had to go and sort of convince some of the powers that be within the organization that it was a good idea and why it was a good idea, because not everybody was immediately bought into, hey, I'm going to be able to push a button, and even if I can control it by role, meaning I can assign the you're allowed to push the button sort of thing to appropriate people, there were still folk that were like, no, you can do that all the way up to QA, but you can't do it in prod.
So then we iterated and matured. So the whole idea here is to get your process going and then do it over and over and over again, and do it better each time. That's where the investment comes. And you do it better by learning from it. So every time something goes wrong, you fix it. Every time you see a 1 in X problem, 1 in 10, 1 in 100 problem, you don't just push retry on the test and try again. You figure out the root cause and you fix it. One of the things that we've discovered is that having reliable tests is everything. As soon as one of your functional tests becomes unreliable, you start having failed CI builds, failed deployments to an environment. It comes back to haunt you very, very quickly if you don't go back and fix it right away.
It's a unique pain currently because we're trying to integrate with some other teams, and we have functional tests that verify that the things that we're integrating with, the upstream dependencies that we're ingesting, are actually working the way that we expect. So we've had a lot more failed builds recently because those services are sometimes up, sometimes down, et cetera, et cetera. So this pain is very present right this second.
And that actually leads to a lot of interesting discussions about how to stage your integration tests and what to mock out and what not to mock out, and how to handle those failure conditions in different environments.
Well, it's also an interesting discussion because people's first sort of knee-jerk reaction to, oh, well, that's a dependency. Do we really need to test that? The answer is yeah, because it's a dependency. They have to operate in a way that you expect in order for you to integrate with it. So their knee-jerk reaction is to just turn that test off. And I've seen this in a lot of people, right? Either the integration test or the smoke test, so further down the line, or even the unit test. So if there's a unit test that's sort of masquerading as a functional test somewhere in your system, the gut reaction of most people will be, oh, it's not working. I just want to commit. I'm just going to turn that one off. Or I'll put the annotation ignored, add ignored.
Yeah.
We don't need that one really, right? And then they'll push that up and everything will succeed. And then somebody will push the button and it'll fail in prod because the test was actually testing something for real.
The other interesting part of this is when you start doing automated tests against other projects that are not doing automated tests, you start finding their problems. So also part of this process.
All of their problems.
Yes. So at this point, we're coming along pretty well. We've got a pretty good pipeline going. We've only got a couple of projects using the pipeline so far. We've kept it sort of within this single team. We haven't expanded out too much. Our pipeline's still a little bit leaky. We still see some problems getting into it. And that leads to the next big topic that we had to address, and that is taking out the garbage. So we had a code review process that was post-commit, which basically meant that you could commit code, it would make it into the baseline, and then there would be reviews notifications sent out. And we would review after the fact what went into the baseline and then go back and fix if necessary. With continuous delivery, that doesn't work out so well because now your garbage is already in the pipeline, already on its way through. So,
it inspires people to ignore it.
yes. So that led to the great debate, as I like to call it, on our team. Our team had grown a bit by this point. We had expanded to quite a few people, and the debate between pre and post commits was long and somewhat painful. It's amazing how strong developers feel about one way or the other. There were arguments that said pre-commit reviews would slow us down, that the process of doing pre-commit reviews, which I'm about to show you, was too complicated. But then there were the arguments that post-commit reviews allowed the garbage to get into our pipeline.
Should note too that, these presenters were on one side of that argument, the other members of the team were on the other side of that argument.
Yes.
We were not eliminated from this argument, and sometimes we were involved in this sort of fisticuffs like, no, you can't change my process. We should identify and point out the fact that change is hard. Doesn't really matter what you're doing. If any of the developers have been doing a certain process for a certain period of time, probably anything more than a week, they've ingrained it into what they're doing. They just do it automatically. Once they get caught there, doing anything else is difficult because you've moved the cheese.
And I will say that I was one of the most vocal post-commit arguers, and I have completely changed my stance on that at this point due to Git and Eggert. So we are using Git and Eggert to do pre-commit reviews. What that allows us to do is to get eyes on code before it makes it into our deployment pipeline. The process is,
I'm gonna play Vanna.
yes, developer fetches the latest code from the Git repository, makes their change, pushes it up to Eggert for review. Very simple thing to do. At that point, we kick off an automated CI build with just that change in it on top of the baseline, way over there, number 3. That verification build then runs our suite of automated tests against that change and provides feedback back to Eggert to indicate whether or not that build has passed the testing verification.
It has essentially like a true-false check mark that just says, this has been verified by our automated process that it looks like it builds and it passes all its tests.
And so that basically provides a green check mark or a red X on your change to say, is it good or not? At that point, then we get eyes on the change. Eggert is wonderful in that it encourages many eyes on the change. We often have 3, 4 different people on our team looking at the same change, posting comments about the change.
Because they all see different things.
They see different things, they see different approaches that could be taken better. It does inspire some debates between different members of the team on the best way to do things, but that's a good thing. That drives closure on those issues, and it drives better code. So at that point, the developer then can take that change and iterate on it and make further changes. I didn't show a line going back to reiterate, but we might go through 5, 6, 10 iterations on a single code change before we're happy with it. And then once we get a buy-off where we allow anybody to give it a +2, but in general the rule is a +2 says you can submit it. But the rule is if somebody else is given a -1, don't overrule that until they've undone their -1 and been satisfied with their concerns. Question?
What keeps the original committer from reviewing their own code and pushing it through the system?
Nothing.
Nothing other than it is frowned upon by the team enough that the original committer will be booed and the change may potentially be reverted.
Possibly public shaming.
Yes.
How crucial would you say that Git is, the tool Git in this process? Like if you were forced to stick with Subversion, would you say you could still do this or not?
So the question is, how crucial is Git to this process, and could you just do this with Subversion? I think the answer is you could still do it with Subversion. The workflow would have to be a little bit different because Git as a distributed tool operates a little differently, which is sort of what provides the ability for Eggert, the other tool, to do what it does. We had Subversion integrated with a review tool. The pre-commit, the post-commit reviews were done by a review board. And you can just as easily write a pre-commit hook for Subversion. The problem at the time was that review board, the tool, didn't have a way to tell Subversion back in a pre-commit way that this has been reviewed and it's been okayed, such that code would be pushed then from review board to master or trunk or whatever your branching style of choice is for that particular day. So yeah, you can do it. I don't know anybody within our organization that is, and it would require effort, right? Because you have to write the pre-commit hook in order to make that work right.
So this was all part of the great debate or brawl, as it could be called on our team. We bit off converting from Subversion to Git and introducing Eggert for pre-commit reviews all in one chunk. It took a little while. It was a learning process for those of us who were not overly familiar with Git. And in my opinion, it was totally worthwhile.
I would agree. He belittles that a little because Git and Eggert were not the only changes we were making at the time. We were also learning Scala and doing a couple of other types of things within the team all at the same time. The retrospective after the fact was kind of like, hey, do we have to bite off so many things at once? Can't we just pick one thing that we're going to modify? Because that's too much change.
How does this affect the size or frequency of code changes that developers push out?
It encourages small change sets, and that's a really good thing. What the pattern that we actually see happening is small changes get reviewed quickly because an individual can review everything that's in them quickly without having to become overwhelmed with the amount of change. And so small changes get through the system like that. When somebody changes too many files and has too many things piled up, the iterations start. We start hitting iteration 10, iteration 15. The reviews come slower. And the process naturally encourages you to avoid that because those changes have a tough time making it through the system.
So what I would additionally observe is that the larger the change set, the less likely you are to want to use Eggert, the tool, in order to actually review that change set. So Eggert has, standard diff. You can look at, here's a file, I can see what it was and what it is now with all the changes and so on and so forth. When the patch set being involved is very small, you can sort of keep that in your head. It's not very hard to sort of look at the diff for a couple of files and grok what it's trying to accomplish and why it's trying to accomplish that. And if you tie it with the commit message, you're sort of like, okay, I understand that. But if it's a patch set that can include something like 25, 26, 30, 40 files, then really the only way that you're going to sort of grok it is to pull it out onto your existing code base and look at it in your IDE and try and understand what changed, what was the mechanism of change for this particular patch set. So generally, absolutely agree with Wally. The smaller they are, the faster they move.
It encourages thinking about a problem in smaller pieces. And again, that's a good thing.
So would you say for continuous delivery, you do require code review for every change?
Absolutely.
Absolutely. Even configuration changes. Simple configuration changes get a code review. Hopefully a quick one.
Oh, sorry. Go ahead.
Do you force the original commit author to be the only patch author?
No. It happens that way, but we do not. So the question was whether or not we force the original committer to be the patch author of all patches that go against that particular change. And the answer is no. Generally, if there's somebody else that has a better idea, we've actually seen it, I think, a handful of times, not often, where somebody else says, hey, I've got a different idea about how this change could happen, and they put that review up. And then sometime quickly followed with, here's the patch set of what I'm thinking. So it's against the same change. And then that might or might not be the thing that gets accepted.
How do you guys deal with patch dependencies for the build log? So it's probably seen that I pull down patch 3 and I make change and push it, but then someone pushes a newer patch.
Yep. So the question is, how do we deal with patch dependencies? The answer is moderately gracefully, because Eggert makes it obvious where patches depend on one another. Like, anytime you look at Eggert, it will tell you this patch set that you've uploaded depends on a patch set that Wally uploaded, and if you look at that patch set, it will tell you, oh, by the way, that one depends on this other one. But it's all in the same interface. So when you're looking at the patch set, you can actually see, like, this patch set, non-rebased, which is a Git term, follows this dependency, and this dependency, and you can actually see whether or not those dependencies have yet been merged. So it will tell you in square brackets, dependency, and then in further square brackets, merged.
I've actually used the tool, but have you run into the issue where I have a second stage commit in there that depends on a patch number of previous?
No. I think that's got more to do with how our workflow works, to be quite honest. Because when we take patch sets in, we cherry pick them into the main branch. So we've sort of eschewed a little bit based on how our CI tool and Garrett interact with one another, the allowing Garrett to do certain types of things. So every change that we make is actually cherry picked into master when we do it.
So one last comment about this is pre-commit reviews and all the debate and iteration that we have leads to more team ownership of the code base, which is a wonderful thing. Means that individual developers do not own changes. Means that at least 2 people have looked at something before it makes it in, hopefully more like 4 or 5, and that we as a team have debated, argued about, come to a conclusion about how certain things should be done before something makes it into the baseline. And that can only make the code better.
It gives the code a standard feeling, which is kind of an odd statement, but when you're looking at the way in which you would make a change to a particular code base, similar to coming to it for the first time, you look at a file and you say, oh, look, all the curly braces are on the ends of the lines and not the beginning. So when you make the change, you're more likely to put all the curly braces on the end of the line because it matches the rest of the file. The same thing is true for patch sets, because you're looking at like, this is the way the system works, and I want this change to fit with how the general system wants to work. So you find people and their commentary amounting to, I want the system to constantly work this way. So you get these very interesting psychodynamic things in the code where the code just all looks the same for the thing that you're producing. It has a very live feel to it.
So this was all working really well for us. And at this point, we started to bring more teams in and started to have more projects doing it. And at that point, we needed something a little bit better than the existing CI infrastructure that we had and the existing scripted deployments that we had. So at that point, we brought in a professional hill, you might call it. I won't name the product, but we brought in a more industrial strength CI and deployment product and converted all of our builds and deployments to use that. We also needed to mature our functional test framework. So we had functional tests. We tend to write them in Python. It's a convenient thing for us. We have resources, testing resources who can help us with Python testing scripts. I find it useful to have the testing scripts written in a language different than our application is implemented in, so that you have a different take on testing. You don't bring over any code from your implementation.
Reduces the amount of sharing.
Question?
How do you minimize downtime during deployments for QA?
Oh, for QA?
Nobody cares about that, right?
We care about dev.
Actually, we're going to talk about that in just a couple
sec.
slides. So we built something that we very creatively call PyFunc test, which is our Python functional test framework. It's just some simple Python written on top of the Python unit test infrastructure. We use that to create smoke tests to run against nodes. We use that to run our basic tests. It makes for a very simple test suite to run. It's very portable, very easy to install on an environment.
The best thing is that at least the testers that work with our team all know Python. So oftentimes we find them writing the tests in advance of the code that we've actually written. So the tests exist before our implementation does.
We also modernized our monitoring infrastructure. So we had monitoring obviously before, but with continuous delivery, you need to understand what's going on in all of your environments because you want to be catching problems early. You want to know when you broke dev, and if you broke dev, you want to know why. And so we extended our monitoring to our QA and dev environments in a much more robust way than we had previously. And we started monitoring our applications as soon as we deployed them. So it wasn't an afterthought. It wasn't something, okay, we're getting ready to go live, let's put the monitoring in place. We put the monitoring in place upfront and early so that we could iterate on it, make it better, and get the immediate feedback from our builds, from our build pipeline, and know more quickly when a change caused some sort of a regression.
It was cool actually for the developers to start thinking about ways in which they would want to know whether or not their software was working correctly in production, mostly because they can't touch prod, right? So if they can't put their hands on it and they can't see things physically, meaning they're not allowed to tail logs and things of that nature, there has to be some mechanism to allow the developer to actually see how is my thing functioning once it gets out there. And this was one of those things.
So to do this, we did what I'll call some cave exploring. Again, I won't name a product, but we found that it was very useful to put together a daily summary for our production environment, and in fact, we're extending this to our QA environment now, of give me the history of everything that happened in the past day. Go grok the application logs and pull out any unexpected exceptions that happened in that environment over the past day. Give me a graph of how often they happened so that when I see a spike, I can go look at it. Give me a history of all we're building a RESTful application here. Give me the HTTP status, response codes for all the calls over the last day, graph them. Make it easy to tell when something strange happens. So we're starting, again, we use this in production already, and we're starting to extend this to our QA environment to help us spot problems quickly.
The coolest thing is seeing them every single day. You can very easily see when something's out of whack, because you can look at them side by side and you can say, this doesn't look the way the one yesterday or the one before that looked. You can see the trends very, very simply.
As we started to bring in more projects, we started to figure out that we had inconsistent deployment environments. We touched on this earlier, but now we're starting to bring in legacy projects, products that exist already in environments, and yes, they do things differently. So we need more robust deployments. And that led us to develop another internal tool that we creatively call libdeploy. It's based on Fabric, as you can guess from the slide. Again, Python, it's convenient. We have people who know it. And this is what we use to deploy applications to any given environment.
So some people might say, well, why not any of the other tools? We happen to have chosen Fabric, but why not Chef or Puppet or what have you? Fabric was part of a sales pitch from elsewhere in the organization for doing something that at the time we thought we needed the capability to do, which was to jump from wherever it was going to be deployed to a jump-off box that was actually in the environment that we were going to deploy to the thing that we were actually going to deploy. So there was like multiple SCP tunnels that had to be created in order to get software put out where it belonged. Turned out that wasn't really necessary based on the tool that we chose to link with libdeploy, so that ant mound that we were talking about earlier, because we were capable of putting agents for those CI and continuous delivery environment things out into the location where we were going to deploy to. So we were using that as our gateway. So the maximum hop between a gateway to deploy and the machine that we were going to deploy to was 1. So libdeploy got chosen, but there wasn't anything that really drove us to Fabric.
And this is where I can belatedly answer the question of how do we avoid downtime in an environment when we're doing a deployment. So libdeploy is set up to do an iterating deployment over an environment. So if we have a QA environment, we'll tend to have 2 nodes behind a load balancer. And our libdeploy scripts will shut down 1 node and take it out of the load balancer, upgrade that 1 node, run smoke tests against it to verify that it's running reasonably, and then put that node back into the load balancer and then move on to the next node. And then once all of the nodes in the environment have been upgraded, we run our basic tests against the load balancer to ensure that the overall product is working properly.
So the other thing to note too is we don't have yet environments that have a lot of things to deploy to, but there are systems in Comcast that do. So at least within our area, the maximum is sort of like 20 machines, give or take, where we would end up having to deploy. And the tool that we've chosen for managing that has the capability to allow us to parallelize deploys. So we can sort of do clusters of 5 if we want to, arbitrary groupings of servers in order to make sure that things don't go down while we're in the process of doing a deploy. The other fun thing to mention here is that there's an additional tool that we developed to deal with the load balancer. when we started this whole escapade with libdeploy, we discovered that our load balancer actually has 2 health checks on it. It has a positive health check that is checking to see that a 200 comes back from the thing, whatever the thing happens to be. There's also a negative health check that is verifying that it always returns a 404. The organization was using the negative health check as a deployment mechanism to take the target host out of the load balancer. So what they would do before, in the manual sense, what they would do is before they went to deploy to a server, they would go touch a file at the location that that negative health check was looking for so that it started returning a 200. And once it started doing that, the load balancer would take it out. The problem that we found with it is that it's completely non-deterministic. You don't know when the load balancer is actually going to run its check, so you don't know when it's going to come out, or even if it has come out, because you can't ask the load balancer, hey, is this one gone? You just know that the load balancer still responds because there's other machines that are responsive. So we wrote a tool to use the load balancer's SOAP interface to actually twiddle a machine out of the pool so that we could deterministically say, this one is no longer in the load balancer, stop sending traffic to it. So we could verify that we were not impacting customers when we did a deploy.
So another note about libdeploy is that we run the same deployment script in every environment. So this isn't a dev libdeploy and QA libdeploy and prod libdeploy. It is libdeploy. And we simply feed it a different configuration for each environment. That way we're practicing our deployments every time we deploy to an environment.
And before anybody asks, libdeploy is fully unit tested. There was one person behind you first.
If there is an app dependent on database upgrade, so how that is controlled?
Terribly. We definitely have the case in some instances where the apps have dependencies on the database. We're trying to decouple that as much as possible. So using sort of asynchronous event processing to shuffle data around so that we're not dependent on the specific schema changes. We are more dependent on the data that gets shuffled from place to place. And that keeps us from having to put those two things together. That's not to say that it never happens. And when it does, we do have to coordinate because right now we don't have database push button, although it would be nice for a variety of reasons.
Just wondering, at what level are you deploying it? Are you like bare metal and you're installing Linux, or are you just deploying a WAR file, or where?
So the question being asked is whether or not we deploy to bare metal. The answer is no. So we are reliant a little bit on an external group to us, inside of our group though, for infrastructure. And what they do is they lay down sort of the worked out commonality that we have discussed with them for us to deploy to. So they install the OS, they make sure that it has the right things. If it's a Tomcat, they make sure that it's the right version. They provide us with Java and things of that nature. But they also provide us with the user that does deploys. So we have negotiated with them to make sure that if we need X, that they can supply it. And then on their side, part of that sort of handshake negotiation is they also have done sort of continuous delivery, continuous deployment, because they have configuration management. So the organization is using CF Engine to make sure that where necessary, all of the things that should be alike are.
Okay.
So, coming towards the end here. Evangelism. You have to take the time, once you have gone through some of these steps, to actually sell, to actually go out and tell people, here's what I've done and here's why it rocks. Because otherwise, they're not exactly going to be beaten down your door. Because what they do right now does work. It just doesn't work consistently and it's not testable. So it's only partially repeatable, especially where humans are involved, right? If there's an individual that has to go and push a button, then it's not testable because there's an individual that has to push a button. Right? You have to be able to tell them, look, I've got faster builds, I've got more builds, I've got better feedback, I've got easier deploys. Once you have all of that sort of evangelized, you also have to do the reverse and ask them, am I giving you what you need? And then try and solve those problems as well. Because if you don't, then they see you as sort of pushing onto them, here's the things that I think you should do. And that's not really true. It's more like, these are the things that are working for me, and they are making me faster, so I want you to be faster too, because I want the organization to succeed. Spend time doing brown bags. where you can sort of demo the things that you've come up with, the statistics that you are collecting, and go and make those handshake agreements with other organizations. Very specifically, what you're trying to do with these handshake agreements is go towards something that's a little generative, rainbows and kitties, right? What you want is people to come and ask you, hey, how can I get on the new hotness? How can I use the thing that you're doing? Because you are faster. I can observe that you're faster. You're able to make changes faster. And look, you can push a button that that guy over there has access to that deploys your code to prod.
Yeah, we've got teams asking us, how do we get there? What's our next step? And we're helping them understand how to get there.
Being generative is sort of like catching more flies with honey, right? If you don't push them away, if you say, here's a system that I have developed and it works, please come and use it, chances are they will. All right, so where did we get to? We had deploys, as I said at the beginning, that were taking multiple hours. Some of the bigger ones were taking multiple hours just because we had a lot of people that were involved sitting on a phone. Some of the ones that Wally and I deal with were more on the order of 30 minutes, sort of smallish, restful services. We got it down to approximately 5 minutes, and that's not just the deploy. That's 5 minutes for Wally to commit a change, myself or somebody else on the team to review it, for it to make it into master with its verify and master builds, and then for somebody to push the button and it show up in prod. 5 total minutes from made a change till I can put it in production for any change we make.
It takes an hour just to run our functional tests.
Your functional testing. We made them fast.
Yes.
If they're tiny and they're only, so one of the things that I've observed, let me rewind a little bit. We'll take unit tests as an example, and specifically individuals or groups that have unit test coverage that is fairly low, because we'll call them legacy development. And I'll do a little waving my hand at legacy development, and I'll say, usually what people's reaction to that is to hands off it, because I'm afraid of making any changes to it. And if they need to make changes to it, they end up with the mentality of writing a very large unit test that looks more like a functional test, does an awful lot of I/O, so it's maybe interacting with a file system, interacting with an external system, et cetera, just to make sure that maybe one function of several hundred lines within their code does what they expect. The problem with that is that it doesn't run quickly, right, as you would observe. Anything that has to do I/O incurs the amount of time that might be involved in that I/O, especially if it's off of the machine that I'm running those tests on. So if it's me running a test to verify somebody else's thing, I'm going to incur whatever the socket timeout is, however long it takes to connect, do I have a connection pool, all of that stuff. The longer that takes, the more likely I am to never do it. So you try and drive that to as low an amount of time as possible, especially in unit tests. In functional, it's not always avoidable, but what you can start to do as you build this up is to make the functional tests run for specific areas that you know have changed. So there are tools out there that we haven't had the need to make use of just based on the size of the things that we're deploying. So from a granularity perspective, our things are not this big, they're this big, so we can sort of get our mind around them. But there are tools out there that will say, they will look at your code and say, here are the things that I know have changed, and here are the functional tests that I know cover those things. So you can be more pointed about the type of tests that get run when you're making changes. Then you can say, I will only run the full suite of functional tests before I go to an environment. So you can restrict that long-running thing to once per environment, or at most once per environment. But that is assuredly advanced, because you have to actually put some thought into how do I determine which are the things that are going to run for the changes that I've made. Does that make sense?
Yeah, when you're saying functional tests, you are talking about like a Selenium web browser.
No. Sort of. Let me rewind my no a little bit. We actually took the slide out. We are very much of the opinion that Selenium and the things that go along with it are more akin to manual testing, and they tend to be pretty fragile. So when we say functional tests, we're really aiming at Did the returning body of a call, so if we're integrating with a service, did the returning body of a call contain the things that we were sort of interested in? We don't necessarily care where, as long as we can get them. Did it return a 200 or did it give me an error? When I gave it bad input, did it tell me 404? Did it tell me 500? Those are the types of functional tests that are particularly meaningful. When we get down to Selenium style tests, that's fragile to us, because if we change a UI, and we do that a lot because our product owners like bike shedding, things move around, Selenium tests break. So we try and limit as much as humanly possible those sort of manual testing through a browser or something that looks like a browser sorts of tests. Not to say that they're not there, just very small. And a lot slower, that's correct. Number of builds that we executed went from, for some of the larger projects, approximately 20 per week to 20 per day. Depends on the thing that we were building. And those numbers discount the verification builds and the builds that go on developer desktops and things of that nature, just because we don't have any way to instrument those things. I was having a conversation with our QA tester, our tester the other day, about what is the total number of test cases that got run. And when we actually added it up over the period of a month for one project, it was 80,000. But we didn't count all of the times that developers ran, because we just can't tell how many times a developer has run them. The developer that happened to be sitting near the conversation said, I just ran them in the past 10 minutes 5 times. That's 3,000 tests that he ran. Or no, I'm sorry, 1,500 tests that he ran 5 times. We have almost no humans. There is somebody that still has to push the button.
You have to account for any performance or load testing and all this? Or
Sure.
Absolutely.
So there are some of our projects that actually, as part of the pipeline, do a load test automatically.
Spin it up, put load against it for 5 minutes, and then measure the performance at that point and tell us, did we have a regression in performance? And that can be part of the pipeline. So Joe was saying almost no humans. Well, I push the button relatively often for our builds to production. I did one today out in the lobby, waiting for a presentation. I've done them on the train. They're really that simple. I'm watching, of course, in our monitoring tools to make sure everything goes well.
He does them by his iPad on VPN.
I have also done that, yes.
So there's not a separate performance group in your company?
The developers have very much interest and very much care in making sure that the things that we develop are performant. So no, strictly speaking, we don't have a separate performance group, because the developers are responsible for making sure that their stuff is scaled to account for what it is that they're going to get. Not true everywhere, but is true for us.
What percentage of your code base is now covered by this process?
By the continuous delivery process. So for the team that we're a part of, all of the things we do are this process. That is not true of the entire organization. I'd say we're probably slightly north of 50% for things that are push button deploys, and probably just slightly north of maybe 15 to 20% in terms of evangelism of unit testing, functional testing, smoke testing, to make sure that we're not breaking anything as we go along. We have a lot of, I'm pointing at the gentleman up front here, we have a lot of manual testing. I'm sorry, I didn't mean to pick you out. We have a lot of manual testing and a lot of mentality around manual testing, where there is actually an individual that has to sit in front of something in order to make sure that the thing passes, where really a lot of those probably could be automated, because they're mostly around data testing. We want to make sure that the right data shows up in the right place, because then the UI will do the right thing.
How long does the build take for this project, for the main project? And also, do you always do a full build versus an incremental?
So the full build versus incremental is mostly a Maven thing, whether or not, depending on whether or not we check out a newer thing or an older thing. In terms of the largest project we have right now, it takes about 15 minutes to run a build, which now that they are also doing some matter of continuous delivery, they're looking at and saying it's too damn long. 15 minutes is forever to get feedback that I've broken something. Especially when, like, for the stuff that we build where it takes 5 minutes, the team also has a sort of unwritten rule that says we won't have a broken build for more than 20.
So if we break a build in an environment, so the deployment fails, we roll back the change if we can't fix it within 20 minutes.
So that you never commit on top of a broken build. And lastly, we have thousands of test cases. They run very, very fast, under 2 minutes for most of them. So right now, there's a mixed answer to that question. We started about 5 weeks ago?
Yep.
5 or 6 weeks ago as a team of 15, which in several retrospectives, all of the people in the team said that's too many. We feel like that's not working out for us. So we actually split them in half. We called the newly formed teams Team Purple and Team Violet, mostly because they're constructed the same people and we didn't want them to actually feel that there was any difference between them because they're working from the same backlog. So the backlog didn't change, although we split the teams in half so that they had an easier time with running through some of the mentality and mechanism that we were using. Yes. So the question was whether or not we're co-located. Both teams are co-located, as is our tester and all of the other things that go with our environment, including the product owner.
And the last one, why do you say project, not a product?
That's more of a wording mentality that Comcast has, not specifically something that I abide by.
Does that mean that both those teams edit the same code base?
Yes.
So you have problems with that?
So the question is whether or not all of the teams edit the same code base. The answer is yes, they do. Have we had problems with that? No. What problems are you asking something specific about problems that?
Yeah, like if they want to, they need to alter some class in the system to add a particular behavior, and that affects other behaviors in the system, and they think that's fine. The other team is confident in that.
So that's where Git and Eggert come into play, and that's where we have many eyes on the code. So both teams, absolutely, yes.
And lastly, profit. This is where the profit comes in. So, what did we learn? You have to start somewhere. Don't let the size of the thing paralyze you. It's real easy to get paralyzed. It's real easy to have analysis paralysis. You have to start somewhere. Just pick something. In some respects, it doesn't really matter what you pick. Sometimes big things are better than not, depending on your environment. Sometimes things that are smaller actually will benefit you. Test, test, test. You have to be highly automated with your tests so that everybody can run them. If they can't run them, they will not maintain them. They will be broken all the time. People are involved. You have to pay attention to the personalities and the agenda of the people that you're talking to, because not everybody's going to buy into this idea immediately, especially where you're sort of destroying their view of the world, where production can only be touched by these special anointed individuals. So you have to be aware of some of those personalities that are involved. Look to combine similar things to a point. So we're a group within Comcast of about 150 people. We've collapsed our various code management and CI and continuous delivery to singular tools. But at the overall size of Comcast, some 100,000 people, that may or may not make sense. So we definitely have instances in the organization where they've attempted to provide the one thing for all, the one ring to rule them all, and it doesn't work all that well. You do have to be willing to let certain size teams, certain groups within the organization experiment with how they do things. It's just a natural matter of course. Be okay with 150 person groups, maybe less, maybe more, depending on how your organization works, determining their own path and picking their own tools. Provide them support for that, because whatever makes them fast is going to make you fast regardless. Have the numbers when you're all said and done. You're going to have to prove that this actually had improvement, that it had some effect on how you deliver your software. By taking the people out, it was more consistent. By making sure that we had unit testing, it was guaranteed that it was going to work when we pushed the button. Those are the types of things you need to collect, and you need to collect them up front and be prepared to do so.
I will say, once you get the ball rolling, though, the benefits are obvious. And that's why we have teams coming to us saying, we want to do this. This is working for everyone.
So, again, I'm Joe Campbell, Twitter @JoeCampbell.
I'm Wally Eggert, Twitter @WallyEggert.
And we're a little over, but if there's any other questions, we'll answer them to the best of our ability.
Does this apply for large UI as well? Because for major site redesigns, and how does that work if you're rolling out this portion of the page?
So the question was whether or not we can use this for large redesigns or individual portions of the page. Really, that's about developer process, right? So that's helping them or encouraging them to make small incremental changes. Sometimes that's a conversation that you have to have with your product owner as well, if you happen to have one, or whatever the business individual is that's trying to drive that, because you can talk them out of, well, we have to do this all at once. And you can talk them down to, I just want to do this module. Can we just do that? Right? So a little conversation about what's the scope of this thing to try and drive, I'm making a change, I'm making a change, I'm making a change. And even if they choose at some future point to want to deliver the whole thing, they can, as long as the team has the ability to do little chunks of it along the way.
I think an important part of our process was to start small and work our way bigger as we learn the lessons.
All right, right behind you.
So what were some of the features of an industrial strength continuous deployment tool that convinced you to move to that from probably Jenkins or whatever you're using?
So the main thing that we sort of played into was workflow. So the tool that we picked has sort of built-in knowledge of this is where the software is, and this is where it's been deployed to, and there's a workflow engine that allows me to specify splits and parallels, and I can do multiple server deploys and things of that nature. So it's got sort of sophisticated mechanisms for determining all of those things. The other part of that too is we didn't want to be in the business of being developers for Jenkins, right? There are tools out there that do this just fine. The other part of that, like, okay, that statement's a little crass, but the other part of that too is we also didn't want to be the curators of plugins, because not all of the plugins work well together. So can you get workflow in Jenkins? Yeah, you can.
And we started out there. That was our initial
where we
implementation. And it was awkward. We were able to do it. We were deploying to multiple environments. It was awkward.
That may have been because of how we had it implemented, but unknown. So as the group looked at other things, there was a tool that better fit what we were trying to do, so we picked that one. Oh, sorry. Right behind you first, and then I'll...
For your functional integration test that depended on external data, what did you use to set up that data?
So the question was, for the functional test that needed data, what do we do to set that data up? I think that's still an ongoing conversation.
Yes, in some places we have internally staged data, so we have essentially feature flags on our application that can turn off the external dependency and use stage data within our application instead to cut off that dependency. And then we can switch that feature flag back to using the real service again. That was where I was talking about some of the single node tests and having to put a particular node in a certain state to run certain tests. Sometimes it's good to run tests against a known response from an external entity and verify that you are processing that known response well. But also sometimes it's important to call the external entity and make sure you're still getting back what you expect from that entity. So essentially we need both.
Right up front.
I had a trick question of sort of time. I wanted to ask you, how long have you been using Go?
Go? No.
Yeah.
Thank you very much.
Yes, thank you.